Welcome to the class hall. Please be seated. Timmy, Timmy, stop flicking Josh in the head. Jane, what are you doing? Get down from there, Jane. Jeez. Well, now you settle down, take out your books because today's lesson is on embeddings, what they are and how they can make your searches more relevant. Any questions, please? Embeddings? Yes, embeddings. So they are a fancy high-dimensional number array that represents meaning. I like to sometimes think of them as like GPS coordinates, but for concepts instead of locations. So, for example, let's say we have these words, cat, dog, and banana. And poop. Yes, Timmy, poop is a word, yes. Anyways, if you take one of those words or phrases, you can embed them into a vector space. And then if you do this, you'd expect cat and dog to be closer together than banana, because cats and dogs share more semantic meaning. And this works for more than just words. You can embed images, products, user behaviors, entire documents, anything you want the AI to understand at a deeper level. But sir, how do you convert a phrase into an embedding? Good question, Josh. You see, all the big AI providers like OpenAI and Anthropic have as part of their offering an embedding generating service. You can send them over a phrase and they will return back the embedding which represents that. And just as an example, we can do that using the OpenAI SDK like this. And to do this on Convex, we would write a little action that wraps it like this. And to test it out, we can pop into the Convex dashboard and take it for a spin. So we pass our phrase as input to the action and out pops a giant array of numbers that represents our embedding. Sir. Yes, Timmy. How would you then search for smelly words, sir? Well, my fecal-philic friend, that's where vector searches come in. You see, with Convex, we can specify what's known as a vector index on our table, like so. You see that dimensions field? Yeah, that's the number of dimensions that is used to represent our phrase. And in the case of OpenAI text embedding 3 small, it's 1,536 dimensions. And so once we have that index, we can search over it in Convex by doing something like this. But sir, you have an error there. Where does the embedding come from? Yes, I was just getting there. You see, to be able to do vector search, you have to first convert your input phrase into an embedding. And don't forget, it's important that we use the same model that we used before, otherwise things won't work as we expect them to. And now we can try this out. See, we get back a list of documents, IDs, and their relevance score. And just quickly, let's write another query that converts from this into an actual set of phrases by looking them up in the database. And we'll do this all in parallel for performance. Let's try calling that again from the Convex dashboard. And we can see now that we have our phrases formatted nicely with our relevance score. Boring. Well, Timmy, I'm going to assume that you mean it looks a bit boring and not that my lesson is boring, because as it so happens, I agree with you. That's why I put together this demo to go along with this lesson. Yes, I call this Embedding Soup. We can add some phrases on this side like apple, cat. Hey, who added that? Yes, as Timmy has noticed, this is a Convex app. So like all Convex apps, every change to the database is automatically synced with everybody else. Anyways, so once we have some phrases in our soup, we can then run that embedding search action that we built earlier. This then shows our matching phrases and their relevance score against them. But sir, when I entered a phrase not a pet, it still comes up with dog as the top answer. So you see, that's a good question. You have to be careful with embeddings in vector search. They are designed to be general question answering services like you might be used to with ChatGPT. When you typed in not a pet, Convex isn't going to run that through a large language model. Instead, it's going to run some fancy maths to efficiently compare the input embedding against each one stored in the index. Well, that's the bell for homework tonight. You should watch the video from 3 Blue and 1 Brown that I've linked down below. That goes into way more detail about embeddings. Thanks everybody. Cheerio.
Bye, sir.